All right, number 26, find the mean, the median, and the mode of this data set. All right, now you notice here, this data set is not given in ascending or descending order, right? So that the first thing you should do, since you have to find the median eventually, is to reorder this, okay? So you say, all right, it's 1, and then 2, 2, 2, 2. You have 4 occurrences of 2, and you have 3, 4, 4, and then 5 and 6. We have 10 numbers here. After you reordered this, make sure you also have 10 numbers so that you have no duplicates and no omission. And then let's find the mean. All right, so to find the mean, okay, well, let's erase this again. You have to add up all of these numbers, right? So let's find the sum. When you add all the numbers together, what do you get? Right? I mean, you can use your calculator, obviously, and you'll find that the sum is going to be 31. Okay, so the mean is, of course, 31 divided by the number of numbers, and that's 10. So the answer is 3.1. Okay, that is your mean. Now the median is, of course, the middle term. Or the average of the 2 middle terms if you have 2 middle terms. And in this case, you do. This is number 5 from the bottom. This is number 5 from the top. And because you have 10 numbers, you end up with 2 middle ones. So the median would be the average of the 2 middle values, which is 2 plus 3 divided by 2, and that's 2.5. And that is your median. The mode is easy. You identify the most frequently occurring number. And since you have 4 occurrences of 2, the answer is 2 occurring 4 times, right? Okay, number 27. Suppose that the weight of the certain animal is normally distributed. As soon as I read this, I start to draw my bell-shaped curve. Practice drawing a nice bell-shaped curve here. The average, the mean is 300 pounds. And the standard deviation, sigma, is 15 pounds, okay? And you know how I often do this. You just make a little tick marks here. This must be 1 standard deviation above the mean, that's 315. The 2 standard deviations above the mean would be 330. And that is exactly the number, fortunately, that I need to identify here. So find the probability that the random one of these animals weighs less than 330 pounds. Okay, so we're asked to find the combination or the sum of this side, which is half of all the population, and then this part here. Now this, you need the table to find out. This half, you already know is 50%, right? So what is this side here? Now, if you have to find the z-score, which is pretty obvious in this case, you can do so. 330 minus 300, all divided by the standard deviation. And that's, of course, 30 divided by 15, that's 2 or 2.0. But I kind of knew this because I started to make these tick marks, right? 15 above 300 and 30 above 200. So this value of 330 pounds happens to have the z-score of 2.0. Now, this area here can be found then using the table right here, and that's 0.4772. That's 47.72%. Okay, so the answer is 50 plus 47.72, and that is 97.72%. And this is the percentage of those animals that weigh less than 330 pounds. Okay, and in fact, almost all of these animals will weigh less than 330 pounds according to this given normal distribution. That would put this particular animal that weighs 330 pounds in the top 3% of the species of the animal, and also puts this particular animal weighing 330 pounds at the 97th percentile. All right, you could also use the extended table if you need to. In this case, you didn't, and you will be given one of these tables on your exam. 2.00, remember 2.00 the last zero goes to the first column. And so you look at this number, 4772, and that is exactly the number you found. Now, do not use the empirical rule, the 68, 95, 99.7 rule. The empirical rule is okay, but if you use the empirical rule, okay, all you get is like 47.5%, which is an approximate number. That's, by the way, half of 40, sorry, half of 95. And so whenever this table is available, you should use one of these tables. All right, finally, number 28. Let's find 3 data sets. You can create your own. So the sets or the solution I'm going to give you right now is just an example. All right, I need to give 3 data sets, each consisting of 5 numbers. And since I have freedom, it's nice to have a 10, 20, 30, 40, 50. That's sort of a standard 5 number set. You can pick, your own. I mean, if you want A to be, like 0, 100, 200, 300, and 400, that's okay too. Now, the B must have the same standard deviation as A, but different mean, okay? So in other words, B and A have to be distributed in the same way. In fact, almost it has to be exactly the same way. And the standard deviation to be equal. So that means I need to have these 5 numbers so that they are 10 apart, and the middle one is the mean. The mean has to be different, okay? So for instance, I can pick the next 5 numbers that are 10 apart, 60, 70, 80, 90, 100. Now, I don't know what the standard deviation is. By the way, the standard deviation of A and B are not equal to 10. You have to do that, deviation squared, add them together, divide that sum by 4, and then take the square root. And I can assure you it's not going to be 10. But you know that the standard deviation of A and B are equal to each other, and the mean is different because the mean of A is 30, the mean of B is 80, okay? But the standard deviation would be the same because their distribution is exactly the same. Now, part C, C has to have the same mean. So the mean has to be 30, which means that the sum of the 5 numbers, whatever they are, must be 150. And the standard deviation of C must be smaller than the standard deviation of A. So I need this to be less spread apart. Okay, now you can do this in different ways. I mean, 28, 29, 30, 31, 32, the distribution is much, much tighter. And so the standard deviation is shorter or is smaller. Now you could have, for instance, 20, 25, 30, 35, 40. And again, the standard deviation of that set would be smaller than the standard deviation of A. But, you don't have to. There are many possible solutions for these last parts of number 28. Okay, so that's it for practice test number 2. I hope you do well on the real test number 2. Have a wonderful day.